In this video, we are going to go over how to solve linear inequalities. So the first part is we're going to talk about something called interval notation. Interval notation is how we'll write our final answers for inequalities as well as when we get to domain and range. So we're going to use these square brackets, and we use these when our number is included. What do we mean by included? That's when we use those closed circles when we're graphing inequalities. We'll kind of talk about this more in a minute. We use round brackets when the number is not included. Or we have an open circle. We also use these round parentheses when we have negative infinity or infinity, because we can never touch negative infinity or infinity. It's a direction. So first we're going to go over, given an inequality, how would we graph it, and how would we write it in interval notation. So I am going to plot 0. I am going to plot the 5 for the inequality. I'm also going to plot its counterpart of -5. Now, when I look at this inequality, it says x is less than 5. So this tells me two things. One, the symbol tells me that it's open because there's not the equal to line underneath. It also tells me it's less than, and less than will go to the left. Now, how do we write this interval notation? So when we're writing an interval notation, we're always going to have the minimum number on the left and the maximum number on the right. So my maximum is 5 because nothing is bigger than 5. And it doesn't touch at 5, so again, it's not included, so we're going to have that round bracket. Now the arrow is going forever to the left. So forever to the left means it's going to go negative forever. So it means our interval notation will be negative infinity to 5. All right, let's look at a few more. This next one says x is greater than or equal to 4. So let's plot 0, let's plot 4, let's plot -4. Now this time, since it has the equal to, I'm going to put a closed circle on 4 and then draw my arrow going this way to the greater than side. So when it's greater than, we're going to go to the right. When it was less than, we went to the left. Now, to write this in interval notation, the minimum number in this case is actually the 4. And we're going to use a square bracket because it's filled in, or a closed circle on 4. Then it's going to the right forever, so we're going to put infinity. All right, using the knowledge that we already just talked about, I would like you to try the third example where it says x is greater than -6. Pause the video now, try this example. When you're ready, play the video. So the first thing you should have done is labeled your number line, then determined what kind of point you were going to have. Since it's not equal to, it's going to be an open circle on -6. And again, this also says greater than, so it's going to go to the right. Our interval notation, well, -6 is the minimum number and it's an open circle, so that leaves me with the round bracket. And it's going to the right forever, so it's going towards infinity forever. Now, if you're going to graph a compound inequality, which is what this is, we're going to graph that x is less than 2 or x is greater than 5. So let's plot 0. Two and 5. Open circle on 2 because it's x is less than 2, no equal to, and less than means it's going to go left. Open circle on 5, greater than means it's going to go right. Now, how do we write this with interval notation? So we're going to need two intervals, one for the left piece and one for the right piece. So my left piece is negative infinity to 2, because it's going to go negative forever and then stop at 2. My right piece is going to start at 5 and then go positive infinity forever. So when we have two pieces, we need to connect them through a U or a union. Basically, it says this and this. So the union piece is really important. All right, let's look at this last one. This one is also a compound inequality, just written slightly differently. And so we're going to have to read this one a little bit backwards. This part says -4 is less than or equal to x. So let's flip that around so x is on the left. So it's really x is greater than or equal to -4. And then if I look at the second half, it says x is less than 9. So let's plot that. Greater than or equal to means closed circle. Greater than or equal to is going to go to the right. Open circle on the 9, and less than means it's going to go left. So basically it's all the values in between -4 and 9. Now let's write this with interval notation. So -4 is the smallest number, 9 is the biggest number. It includes -4, so we're going to put a square bracket. It doesn't include 9, so we're going to put a round bracket. All right, now we're going to do a couple of different things. Well, along the same lines. First, we're going to solve each of these inequalities. After we solve, we're going to graph and write the answer in interval notations. We got a couple things we got to do, but we have to solve it first. So we're going to use our same solving rules as with equations. So I am going to move the smaller x over to the other side. You could have also minus the 5. So I'm going to have 8 is greater than 2x minus 10. I'm going to add the 10. I'm going to get 18 is greater than 2x. I'm going to divide by 2. And I'm going to get 9 is greater than x. Now, I really want to write that with the x on the left, so it's going to have to totally flip and become x is less than 9. All right, now let's graph this. So I'm going to draw my number line. I'm going to put 0, 9, and -9. Then it says x is less than 9, so no equal to symbol, so I'm going to have an open circle on 9, and then less than is going to go to the left. Now let's write this in interval notation. So 9 is the maximum, but it doesn't include, so it's going to be a parentheses, and it's going to the left forever, so that's going to be -infinity. All right, let's try number 4. So again, I have variables on both sides. This time, I'm actually going to move this x over, so minus x minus x. You could have also added the 2x. So I'm going to have 4 minus 3x is less than 16. I want to get the variable alone, so I'm going to minus the 4. So I'll get -3x is less than 12. Now, this is a really special rule that we have to remember. When you divide or multiply by a negative number, you must flip your sign. So now, instead of it being less than, it's going to become x is greater than -4. Now, if we're going to graph that, I'm going to plot 0, -4, and 4. I will put an open circle on -4, and then greater than will go to the right. So when I write this in interval notation, I'm going to abbreviate that with IN. -4 is my minimum and not included, and it goes to infinity forever. In infinity, we always use a round parentheses. All right, I'd like you to try the next 2 examples on your own. When you're ready, play the video. All right, in this next example, I am going to get the variable alone by moving the x first. I'm minusing the 4x to the 6x, which will be 2x plus 12 is less than or equal to 18. Now I want to get the variable alone. So I'm moving a positive 12 by subtracting 12. And then lastly, I need to divide by 2. Since I'm not dividing by a negative, it's just going to stay x is less than or equal to 3. Now the graph of this, I'm going to plot 0, 3, and -3. put a closed circle on 3, and it's less than, so less than is going to go left. My interval notation, 3 is the maximum and included, so I'm going to use a square bracket. It's going to the left forever, so that'll be negative infinity with a round bracket. On the last one, first we're going to distribute. So I multiply 2 times x and 2 times negative 4 to get 2x minus 8. Then I want to get the x's all on the same side, so I'm going to minus an x over, which again is really like subtracting a 1x. So I'm going to have x minus 8 is less than or equal to 9. To finish getting the x alone, I'm going to add 8. Now my number line, 0, 17, negative 17. I'm going to put a closed circle on 17, and it's less than or equal to, so it's going to go to the left. My interval notation, (17) is the maximum, and it goes left forever, so negative infinity is the minimum. All right, now that we've worked on single inequalities, we're going to work on some compound inequalities. And this is basically just more than one inequality put together. So when we have an inequality that looks like this first one, notice there are 2 inequality symbols in the same problem. So basically this means instead of just having 2 sides of the inequality, there's actually 3 sides of the inequality. So my goal is to still get the variable alone. So I want to get this x alone. So that means I need to move this positive 5 by subtracting 5. So normally I would just subtract it to both sides, but there's actually a third side way over here. So now x is going to be left in the middle alone. I'm going to have negative 6 on the left and positive 4 on the right. So now that the x is alone in the middle, I know I'm done and ready to graph. So I'm going to plot 0, 4, and negative 6 with an open circle on either side. And since x is bigger than negative 6, it's going to go to the right, but x is less than 4, so it's going to go to the left. So it's all the numbers between negative 6 and 4. All right, let's get to this last one. So now we have an OR. So I'm going to solve the left inequality, then I'm going to solve the right inequality, and then I'm going to graph them all on one graph. So first I want to get the 2x alone, and I have a negative 5, so I'm going to add 5. I would get 2x is less than 12, so I'm going to have x is less than 6. Or, to solve this side, I want to get the 3x alone, so I'm going to add 9. 3x is greater than 24. Divide by 3, x is going to be greater than 8. So I have x is less than 6, or x is greater than 8. So let's plot those on our number line. 0, 6, 8. X is less than 6, so open circle and going to the left. X is greater than 8, so open circle at 8 going to the right.